This is Jeff Mucci with RCR Wireless News, and today we're with Paul Evans, Director of Business Development for IMG Systems, which is the business unit that's responsible for launching a new developer toolkit. So Paul, thanks for joining us today.
Yeah, thanks, Jeff.
So, Imagination Technologies, I looked at your website. You got you operate in 15 countries. You have 1,700 employees. You have a bunch of target markets you operate in. You shipped 1.3 billion units last year, which equated to 3.6 million per day and 50 per second. Why on earth would you use Kickstarter to launch a developer toolkit?
Yeah, so good question. So I think, we're obviously Imagination very successful, as you mentioned, in the silicon IP, working with a lot of our partners, major silicon people that I'm sure you heard of, MediaTek, Samsungs of the world, etc. And we sell to those companies IP building blocks, which they take, integrate onto their silicon, and use to, build up solutions they're looking for. What we're doing here with the Creator Kit, and Creator's a member of a sort of family of bits and pieces that we're putting together. We've already launched CI20 sort of last year. It was around sort of a personal microcomputer. And this kit here is about the Creator Ci40. And why that's a little bit different, if you like, to say what the rest of the company is busy doing, is really that's taking silicon that's available in the marketplace, either partner silicon or bits and pieces that we produce for references and that type of thing, and then building upon that so that we open ecosystems. And of course, with IoT, as it is at the moment, we think that's a very important marketplace. Obviously, there's all these big numbers being bounded around, 20 billion, 30 billion, that type of thing. And when we started looking at the market, actually we found there's thousands of different standards, different companies and players in all of this. And so what we wanted to do is effectively find a way through that ourselves. And as we did that, we put together the kit, and we thought, hey, this would be a great kit to deliver into those ecosystems for other people to use. And so it's a little bit, if you like, outside Imagination's normal remit, but at the same time, it's very beneficial to grow those ecosystems. So, yeah.
Talk about some of the markets you operate in today and what you're providing to those markets, and then we'll talk a bit about some of your target markets going forward.
Yeah, so obviously Imagination as a whole, the markets that we operate in today, very much selling, as I mentioned, to silicon vendors. So the types of people where you'd find application processors, that's obviously the PowerVR, graphics, you find that in a lot of mobile phones. Then on the MIPS side of things, you're going to find that in a lot of networking type equipment, bits and pieces through into the embedded world. We might find it in everything from speakers, set-top boxes, networking equipment, as I mentioned. There might be home routers or professional routers and all that type of equipment. We also work with, our Insigma group does a lot of the things like Wi-Fi and broadcast TV as well. So quite a broad range, if you like, of the silicon market.
How does the Creator Board help you engage the academic and professional and the do-it-yourself or maker community?
Right, so I think you're spot on there, Jeff, and that's where the kit is really designed to go and engage those wider ecosystems. So here what we're doing is putting into people's hands. So you mentioned universities, for example. So if you're at a university, now you've suddenly got a kit that stretches from cloud at one side, so you can have computer scientists and things like that involved, down to the other side where you've got an embedded device, and you might have somebody who's designing a sensor or something like that as a PCB that can plug in right the way through up to using microcontrollers, then up to your sort of bigger sort of CPUs and things on hubs and whatnot, doing network and routing, and then, like I said, into the cloud. And because it comes in a kit form, universities or developers or small, medium-sized enterprises, anybody like that can pick it up and say, okay, where's my value add in this chain, and how do I get started, plug these things together, and without having to, if you like, dive down into the nitty-gritty of every single component, get started in a real IoT world.
Interesting, because traditional channels that you distribute through tend to be the traditional silicon guys, and here you are with what appears to be a real grassroots direct-to-developer community development program.
Yes, absolutely it is, yes.
So why don't we pull up the slide and maybe talk a little bit about how this program works and what your expectations are with the Kickstarter program.
Sure, let's do that. Okay, so I'll just kick off here. Just as we've been talking about, a little bit of background on Imagination Technologies and what it is we do. Just as you mentioned, Jeff, traditionally, here's the sort of idea of an SoC, and into that SoC are the various blocks and digital blocks that go up to build some of those bigger SoCs. And as you can see, PowerVR, that's certainly a good if you like, footprint for imagination, and that's on the graphics side. That's the type of thing you find in your mobile phone. Again, under the PowerVR, we also do the vision processing, video encoding, MIPS. Of course, many of your listeners will be very familiar with the MIPS CPU and its sort of heritage there. And then also, I mentioned the Insigma block, as we were just talking a little earlier. That's the, if you like, the connectivity piece. Now, silicon customers will obviously take different parts of those IP offerings and mix them together, and there's different configurations to produce multiple different types of chips, etc. And what we've done, like I said, is take one of those that's applicable for the IoT and use that to develop around to build this kit. And then interestingly, just on the left-hand side here, you can see the cloud. So as Imagination, we also offer a number of cloud services. So once you've got your device and you connect it up through the internet, and you've got then the ability to do things like to store data, start looking at device management. So by that I mean being able to interrogate the device and sort of figure out what versions of software are on there. You can do over-the-air updates and a number of cloud if you like functionalities around that machine-to-machine aspect. Mm-hmm. In particular, I think focusing down on the kit. I think Internet of Things is obviously a big buzzword at the moment, and so we sort of looked at, okay, well, what are the different sectors? How can Imagination bring something to that party? Who can we help benefit, and how would we go about that? So, just some of the examples, areas that we're involved in: healthcare, energy, agriculture. Really right across the board, as you can see in the list there. And again, these are all markets that we've either been directly involved in or are serving, or the kit itself can actually bring some kind of benefit, and we'll get into that in a moment. So if we sort of, if you like, get to the main point here, this is the Ci40 IoT kit. We've gone ahead and launched this on Kickstarter, and it's going really quite successful at the moment. We're very pleased with that, and we obviously hope that continues. There's a lot to bring there.
Now, I got to interrupt you for a minute. So I checked the Kickstarter program yesterday, and your target amount you wanted to raise was $30,000, and to date you've got 228 contributors raising about $27,000. How'd you come up with the $30,000?
So we looked at a figure that would, as I mentioned, we developed the kit, and internally here at Imagination, we've obviously looked at IoT quite a number of times. And what we said was we'd like to bring the kit to market to exactly like you said, to sort of consumers and developers and people that perhaps we don't normally touch. And so we looked at the sort of amounts of dollars, if you were, that it would be involved to just go through and do, okay, well, let's take what we've got and push it the last step. So let's do things like get it certified, let's build communities around that, examples and bits and pieces. And so we felt that was enough if you like sort of an injection to take that extra step that we wouldn't necessarily normally go to. And it's also, as well, the Kickstarter, we feel, is a great vehicle for people to feed back to us what they find useful about the board, what they like about it, what they don't like about it. And so also it's a good way of engaging, if you like, with those communities. Okay,
and then the Raspberry Pi announced their $5 kit. a couple of weeks ago, and they apparently sold out in the first day by giving it away. And I've read, I think somewhere, that the price point for your kit is about $65. Can you maybe compare and contrast the Ci40 kit, the Raspberry Pi kit, and other kits that might be out in the market today?
Yes, certainly can. So with the Raspberry Pi, obviously they've gone for that mini computer world. What we're trying to do here is something slightly different. So if I take the picture that's sort of on screen now, starting at the left-hand side, you've got the Creator Ci40. That's the main board, and so here what you're looking at is an IoT hub, if you like, or something that's close to a router and access point. It brings you things like the Ethernet as a sort of way in and way out, Wi-Fi, AC 2x2, so you can imagine that's a lot of bandwidth for moving things around. You've got Bluetooth low energy, an 802.15.4 radio. That's the same physical radio that you use to build things like 6LoWPAN, or you might build Zigbee off the same radio, Thread off the same radio. And then around that board as well, you can see in the picture towards the top, there's quite a number of different interfaces to allow expansion to go on, and things like audio, etc., to bring out. So rather than trying to go down to the sort of $5 market that you mentioned, this is very much more about getting developers started with an IoT solution that you might find in industrial applications, in home automation, and that type of thing. So it really is, if you like, a very different market. And if I move across in the picture to the middle, we've provided with this not just a single development board, but as you can see in the middle of the picture there, these two 6LoWPAN clicker expansion boards. And what those are, on the back of those, you've got sort of a couple of slots for batteries. So you can imagine these boards are now completely independent. They use the 6LoWPAN RF standard to communicate back to the hub. And then onto those boards, you can add a number of the click sensors from microelectronica. And so in our kit, we've put 3 of those. So the sort of temperature sensor, PIR motion sensor, and a relay. So if you wanted to do some kind of action, turn something on or off or whatever, you've got your basics of an actuator there. And what you can do is slot those into 6LoWPAN clickers and have those move around, your room or whatever, and communicate back to the hub. And that sort of gets you going. But what we envisage is that people will actually come along and buy not only multiple sensors, but also multiple of these 6LoWPAN clicker boards through microelectronica, and be able to build up multiple different systems. And if you're a development person, then you're working on one particular project, you use a particular set of sensors, then like maybe say the ones we have in the kit here, and then you might start a new project. Let's say it's some kind of agriculture project, and you might change the sensors for things like nitrogen sensors, moisture sensors, humidity sensors, or whatever you might have in your greenhouse or that type of thing. And you could very quickly then build up all the bits and pieces that you want to basically address that vertical.
Okay. Well, before we move on to how it works, I do have 2 other questions for you. First one deals with open source. You've got the free access to FlowCloud and that sort of thing. How do you see, do you have a strategy for embracing the open source community?
Yes, very much so. So on the board itself, in terms of the sort of software, we have OpenWRT on there, which, as I'm sure you know, is already an open source Linux distribution, and we're contributing to that by upstreaming the various bits and pieces that go around with the board. Then on the 6LoWPAN clickers, we're using Contiki as a sort of RTOS on that board for control on the microcontroller. Again, that's open source, and we very much intend to upstream all those bits and pieces and again communicate there. So on top of just the operating systems, the sort of next level up, the middleware, we're open sourcing what we're doing with LWM2M. That's the protocols that we're using for device management. So those are open sourced. as is the co-app, the constrained application. And then on top of that, again, we then layer on the application layer, we have a number of examples and references. And I think just today on Kickstarter, we announced a few stretch goals to go even further on some of those applications. And again, the intent there is that that's all open sourced, it's available on GitHub, and people can go in, use that to sort of get started and understand a bit more of the ins and outs of how to, stitch together some of these IoT systems.
Got it. Well, the second area of question I have before we move on is the last 2 weeks have been big weeks for cellular technology and IoT. You had Orange announce both LoRa trials, and they also announced with Ericsson doing GSM and LTE IoT trials with low-cost chips from Sequans. And then you had Verizon announce that they were opening up their network to connected devices and parsing off a portion of their network only for IoT. So you have this cellular technology going down one path for IoT, and then you have the unlicensed technologies attacking IoT. During my conversation this morning with Ericsson, they talked about the intersection potentially being a gateway of sorts that has a SIM card, and then it would connect into a board like this, and you would see the connectivity to the Zigbee or other unlicensed type spectrum. So is one potential use of this actually being implemented in some sort of gateway that connects the licensed world with the unlicensed world?
So I think very much, again, looking at the Ci40 itself, you can see there's some of the, on the top part of the board, there's 2 slots for the sort of micro E-bus. And interestingly, one of the clickers is the sort of GSM module. And very much what we envisage is people being able to take different modules and plug those in. And absolutely, I can imagine that if you like, as you said, the intersection of those 2 worlds can come down onto a board like this. In fact, the board is designed so that if you have some of these different radio standards or whatever in whichever frequencies or whatever, you can add boards that will pretty much plug into there and then allow you to interface and go off onto another standard. So maybe it's something like you mentioned, the Zigbee. Maybe it's something that the board doesn't have built in as a radio today. Let's say it's a 400 megahertz standard, just as an example. You can plug that into the slot, connect that in, goes through the main SoC, and then back out through the Ethernet, or maybe even onto another wireless standard and back out. And very much, I think this board will do that. Yeah.
Earlier this week, we actually had a conversation with the chair of the IEEE IoT group, and you mentioned in the opening comment that the myriad of standards out there. How do you see the IEEE standards world fitting into this type of board? And again, maybe it's the intersection of the licensed and unlicensed world, but I'm just curious how you build in the IEEE unlicensed standards into this platform.
So I think the board, in terms of the hardware, there has the capability of addressing a myriad of different things, and I think those interactions will come through, if you like, people wanting to bring the 2 different worlds together. So back to your point about open source, I mean, we envisage ourselves doing a fair amount of work there, but because this is open source and because the board is so flexible, as people want to bring those different standards together, or even different ecosystems together, I think this is a board, if you like, is itself a gateway for doing that. And that's kind of how I see those worlds joining.
And I didn't hear you mention a slot for a SIM card. How would you see, if it's going to be the intersection point between the licensed and unlicensed world, how would you see integrating a SIM card into this type of kit?
So I mentioned there was a GSM card, for example, from Microelectronica, and I believe that card has a slot for a SIM card on it. So I think there's definitely ways of joining those together. And one of the things I haven't talked about is the number of click sensors and boards that are out there. I think there's well over 100. And as I mentioned, I know one of them is that GSM clicker, and you click it in, you add the SIM card, or assuming that's what you want to do, and off you go, and the 2 worlds are joined. And in fact, an interesting application of that, we're working with a company in Portugal who are doing monitoring of blueberries on a farm. And of course, they can. One of the things they want to be able to do is basically have almost like a failover system. So if one of the standards goes down, let's say you've joined the boards together with Zigbee or Wi-Fi, and you lose that they can also use the cellular network then to send a signal from boards that are further out in the field and saying, hey, help me, my battery's run out, or I've lost my other connection via whichever channel. So it's almost like having multiple of those standards through the board is definitely beneficial for some applications.
Got it. Well, that's an excellent overview of what Creator Ci40 is. Now let's move into how it actually works.
Sure, absolutely. So I think the easiest way for me to explain this is sort of use a few pictures here and build up some of the steps. So if you imagine that you're starting your application, you want to do something, and let's just say that as the sensor shows here, you've got some kind of PIR motion sensor. You want to detect that somebody's come into a room. Maybe it's to turn the lights on, maybe it's to set an alarm off, or whatever. You've got an idea of what your application might require in terms of sensors, and so you get hold of those sensors. The next thing you do is, we provided in the kit basically the clicker, and as I mentioned, that's remote. It's got the batteries and things on the back, and you just basically get hold of your clicker. It's got the 6 low-pan connectivity on it. It's got a little microcontroller there from Microchip, PIC series there, PIC32. You then plug those together. You set up a comms link between your sensor and the main hub. We've shown 6 low-pan, but again, the board itself will support also Wi-Fi and Bluetooth low energy as well. And then, as we've just been talking about, you can always expand that by adding more of whatever your favorite RF standard is through the microbus onto the main hub. So this is like one of many communication standards that you could use, but we'll follow down that line. You now have multiple of those, so you can imagine, again, an application isn't just going to do one single thing, it's going to end up doing multiple things. So we talked about the PIR, so you've sensed that somebody's in a room, that's great. So now what? Well, now I want to turn the lights on, or now I want to heat the room or cool the room, or I want to turn my speakers on and off, that type of thing. And so all of those different sensors that are some kind of interface out to the real world can connect up through the board, and all that information is then passed up into the cloud. And of course, the cloud is where you'd, if you like, make sense of a lot of that application. You could also do a fair amount of it on the SoC that's on the board as well. And then, it really is just opening the world up, right? So what sensors do you want? How many do you want? And obviously loading those boards or multiple of those boards. So that's how if you like, we plug all the things together in just a few easy steps. I did just mention there that you run the application in the cloud. Well, sometimes that's true, and you put all the application and the analysis in the cloud. But sometimes you run a lot of the application or potentially off the hub itself, and then only communicate up to the cloud when you want to send the actual data backwards and forwards. And so one of the things we've done here is we've got a pretty powerful SoC on the board, and that's a dual-core, dual-threaded MIPS processor. I've already mentioned the Wi-Fi, obviously that's through our own Sigma group, and then all the other multiple bits and pieces. I've just spotted something on this slide, which I should have mentioned earlier, and that's the TPM. So, of course, one of the issues I think with IoT that we hear about all the time is security, and so we basically place the TPM chip on the board so that people have a way of doing secure boot and one thing another, so that they can have their trusted zones around the SoC and make sure that they've got the appropriate keys and one thing another. And I think that's a very important aspect to IoT. We see a lot of if you like, equipment that's traditionally just been bits of embedded equipment that is now becoming connected, and if we just put the connectivity, slap that straight on without thinking about the security, then obviously we'll open ourselves up to attacks and one thing or another. So very important aspect.
Got it.
keep moving down. You already asked earlier about the the commitment to sort of open source and what's going on there, and I mentioned the OpenWRT. It's also the case that this board, we're going to have a Debian distribution on that, and also Brillo as well. So Brillo's, I'm sure you may have heard of, this is the new operating system from the Google team, and then we're already a member, if you like, of the Brillo program, and so it will tend to put together there a golden reference platform. And I think you've probably seen the announcements from Google, they're supporting all the main CPU architectures with Brillo, and this is part of that program as well. Okay, so moving on, looking a little bit more now about the cloud side of things. So we did mention that, yep, we offer access to FlowCloud. It's free to get you started, kind of thing. And there's a number of services that FlowCloud offer the developer community and things to get started. Obviously, there's the capturing of the data as you get it, so that basic M2M type service. Then being able to provision the devices, doing authentication, registration, and then also moving beyond that, we do offer a number of other services, like we have containers and those type of ideas, so you can host your application, databases as a service, so you can obviously expand and contract the amount of bandwidth and storage and those type of things that you require. And then even going beyond that again, as imagination, we do offer some other sort of cloud services. So for example, voice over IP. You can imagine that you might want to make a call from some embedded device and have that go up through to the cloud. And again, these are all services that people can access through the FlowCloud system.
Got it.
So then, carrying on the theme actually of the open source, I just wanted to give you here a picture of the software, because, and this is very interesting, and right back to your first question of why one of the reasons we're sort of doing this through Kickstarter. When we went to engage in various IoT projects, we'd sort of find, okay, well, we need the hardware to go with it, but actually the software aspect, it can be a very, very large piece of any project, and certainly a very involved piece of an IoT project. And so we basically put these structures together, and these are examples that we're going to put up onto GitHub and make available as open source. And I'm just going to quickly touch on the next slide, just to give you again some idea of the depth of those. And again, these are all, if you like, references that people.
No, I got to interrupt here. So is Imagination built the full IoT stack, the reference stack?
So we have built, I would say, a reference stack. Obviously, depending on what you're doing with IoT, you may choose a number of different flavors of what you do, either in your operating system or middleware or one thing or another. So what we've done here is put together a reference example, so you can sort of navigate your way through that minefield. We've built it in such a way that these sections are modular. And so, if you wanted to take out one particular standard and put another one in. So, for example, on this picture here, we've shown, we built this up using the sort of 6LoWPAN, if you like, built on that 802.15.4 radio. But let's say you wanted to put sort of Bluetooth in there, or Zigbee or something like that. You can take one module out and place another one in. So, yes, we built a reference stack. But certainly not, if you like, the reference stack. I'm sure there's many people have different thoughts and ideas on how to do this.
What are some of the other key takeaways we should understand from that previous slide? I'm sorry, going back to
I'm sorry, yep.
Okay.
I think some of the key takeaways for me, some of the very interesting parts that we've put in here, you can see this sort of thread running through the sort of middle of the slide, LWM2M, and this is about the lightweight machine-to-machine sort of device management, and so here's an example where we've really stretched that device management from the cloud on the right hand side down to your IoT hub in the middle where you kind of expect it, and then over onto the the embedded device itself. And the reasons you might do that, of course, is on the cloud side of things. You can imagine that, okay, well, I want to, you might be running some kind of business, and you want to check, okay, well, what are all these devices doing? What's the battery level? How many of them are on? How long have it been since they reported in? What versions of firmware have I got out there? Are people updating correctly? And so having that device management capability across all these devices, I think is a very important aspect. Do you need it to get your connected doorbell or whatever connected to the internet? No, and certainly as just perhaps a hobbyist or whatever, you wouldn't necessarily do that. But if you're developing and it's a sort of small, medium-sized enterprise, or even a larger enterprise, then suddenly those are the things that might become important to you. And again, we've taken a lot of open standards, brought those together, like LWM2M is an open standard, for example, brought that together, used that protocol, and again, painted a picture of how you would go about assembling an IoT system.
What level of software development skills do you need to be able to use the kit and the board?
So I would say that it's something for people that are familiar with sort of either C or Linux. It's not a something that's, say, targeted at sort of schools or that type of thing. If you could imagine, say, rather than school, if you're thinking more college or university upwards, then it's that type of fit.
Mm-hmm. Do you see, earlier this year you had the CEO of General Electric and the CEO of Bosch talking about transforming those industrial conglomerates into digital companies. So their internal IT teams and product teams are going to have to take the existing command and control systems that they have and then adapt them for some sort of wireless and RF connectivity with the user interface applications. As you look at your distribution strategy for this product, do you see working directly with those types of enterprises, or do you see working more directly with carriers, mobile operators, to build vertical stacks?
So I think that's a very interesting question, because actually I think there will be working with quite a number of people. I think one of the things that obviously is emerging, if you like, from the IoT world is that there is going to be disruption from that, and consequently I think perhaps industries that were perhaps happily operating in their own vertical or silo and doing very well in that are now having to sort of face these questions of, okay, well, how do we operate with this as these changes come? And I think cloud is a very good example of that. I mean, even in this project, we're talking about having free access to FlowCloud, and there's a number of services in there, but it's not every service. So, for example, we don't have a weather service, and if you wanted to build an application with a weather service in it, you need that collaboration. And I think the same collaboration across these various industries is going to become a requirement. Because of the IoT.
Yeah, I mean, we live here in Austin, Texas, and IBM is just down the street. They've got their Blue Mix IoT platform in place, and you mentioned weather. IBM just bought the Weather Channel data. So when you think of the Watson offering, and just the sheer amount of data that's going to come out of all these sensors, and when you combine that with predictive weather algorithms, there's really going to be some interesting things that are going to happen down the road. I guess since you do this every day and look at it every day, do you have any big predictions for 2016 in terms of IoT adoption?
Well, I think that, where we as an industry are today, we're sort of in that version 1.0. I think there's lots of people experimenting with lots of really great ideas. And as you mentioned, taking that data, and I think we've got to get to the point of from just taking data per se and turning data into information. I don't necessarily know about the next year, 2016 or 17, but I think within that 2 to 3 years, I really believe there'll be an explosion of turning data into information. And just as you're saying, combining those bits and pieces is going to bring very, very powerful algorithms. And I also think it'll bring new businesses and new opportunities with that.
Well, let's go to the last slide, and I guess the magic question here is how do you get involved with the IMG community?
So getting involved with our Kickstarter, which is live now. I think it runs through to sort of 23rd of December, if I remember correctly. So anybody who wants to get involved can either go to the URL that you see here, Imagination site, and click on that, and I'll take you to the right place in the Kickstarter. Also, just to give your listeners some kind of vision, if you like, around the timescales of where we are today. So we've been working on this project internally for a while, starting sort of a year ago. We've had the boards inside. We've been doing some of our own dog fooding and alpha testing and one thing and another. And now we've got to the stage where we feel sort of confident around that. We've put it out on the Kickstarter, which started at the end of November. We're in that period where, we're going around the software, making sure we get the Q&A testing right, making sure we get the production software right, and making sure all those things that, as you were asking earlier about, hey, what are we using the funds for, that last step to bring this out to the various ecosystems and developer communities. Our target is to get that together for the March-April timeframe, so spring 2016. And yeah, for anybody that wants to get involved, go check us out on Kickstarter. That'd be great.
Well, Paul, thanks for your time today. I really appreciate the overview.
Okay. Thank you very much.